Let's take a look at a chi-square distribution example. First, let's look at some background information. Chi-square compares observed values to expected values and is a non-negative distribution. Chi-square is based on degrees of freedom and becomes more symmetrical as degrees of freedom increase. Now let's look at an example. A report done states the weekly number of instant noodle packs college students eat. 20% don't eat instant noodles, 35% eat 1 pack, 25% eat 2 packs, 15% eat 3 packs, and 5% eat 4 or more packs. Most college students were surveyed and the results were as follows. 35 said they don't eat instant noodles, 85 eat 1 pack a week, 40 eat 2 packs a week, 30 eat 3 packs a week, and 10 eat 4 or more packs a week. Using the 5% significant level, can we conclude that the survey is consistent with the report? Based on the information from the example, we can set up the following table. The table shows figures pulled from the report and figures pulled from the survey, and how they are related to the number of packs of instant noodles. To find the expected frequencies, we must multiply each of the percentages from the report by the total frequency observed. After doing so, we can fill in the frequency expected column. We must now start going through the steps. Step 1. State the null and alternative hypotheses. The null in this case is there is no difference between the observed and expected frequencies. The alternative is there is a difference between the observed and expected frequencies. Step 2. State the alpha, which in this case is 5%. Step 3. Select the critical value. To find the critical value, we need to look at the degrees of freedom and the alpha value. The degree of freedom is the number of categories minus 1, which in this case is 4. The alpha value, as we already know, is 0.05. The critical value is where these points intersect. As you can see on the chart, the critical value is 9.49. Step 4. State the decision rule. Since chi-square is a non-negative distribution, the test will always be a right-tailed test. The rule for this example is, if the test statistic is greater than 9.49, we will reject the null hypothesis. Step 5. Calculate the sample statistic. To do so, we must use the following equation for each category. After doing so, here are the equations we get for 0 packs, 1 pack, 2 packs, 3 packs, and 4 or more packs. We now fill in these values into the table and sum them up to get a value of 5.84. Our final step is to interpret our results. Since 5.84 is less than 9.49, we fail to reject the null. Based on this sample, we can conclude that there is no difference between frequencies observed and frequencies expected. Thanks for listening, and good luck using chi-squared.